Homework help for section 7.1 asks you to solve systems of equations algebraically. So I've got two systems that I'll do for you today. One system where one equation is linear, in other words no squared terms, and the other equation does have squared terms, and the strategies that we would use when we see that. And then the second system, both equations have not only squared terms but a cubic term, and that kind of tells me there's a strategy I probably should do for that one. Alright, so looking at the first one, like we mentioned in class, anytime that you have one equation that is completely linear and the other equation that has any squares in it, a lot of times it's a good idea to take the linear equation and solve it for x or y. So I am going to take this equation over here and I'm going to solve it for x or y, and it doesn't matter. I notice that if I divided by 7, I would end up with 2 fractions, or if I divide by 3, I only end up with 1. So I'm going to solve for x. So I'm just going to rewrite this here for now. So solving for x, I'm going to have to add 7y to the right side, subtract 6, and then of course divide by 3. Alright, and so there's what x is equal to. And if we said that x was equal to 4, we would just take 4, plug it in here, and solve for y. Well, I'm going to do virtually the same thing, it's just it's not a number. So now I'm going to take x and replace it here. Copying that equation down, it's x, or we said that x is 7/3 y minus 2 squared, so there's x squared. Continuing to finish that equation, it's minus y squared is equal to 4. And now you notice we've gotten rid of one of the variables, which was what the goal is. Alright, so now I'm going to have to multiply this out, or FOIL. You see it's a quantity being added or subtracted, you're squaring. So squaring the first term is going to give me 49/9. If this helps to do both sets of parentheses when you're doing the FOILing, please do so. If you can't, just do it without looking at the parentheses. So it's 49/9 y squared. If I did the insides, it would give me negative 14/3 y. The outsides would also give me a negative 14/3 y. So I have a total of negative 28/3 y plus 4. So there is that parenthesis squared or FOILed. Still have the minus y squared, and it still equals 4. And now I see it's quadratic, so it tells me I probably don't want to have the 4 here. I want to subtract 4. I get lucky here. These 4's actually just cancel. Going to combine the y squared terms. This is really negative 9/9 y squared, so combining with 49/9, it's going to give me a total of 40/9 y squared minus 28/3 y equals 0. And we get very lucky here because there's no constant in the back. It's a quadratic, there's no constant. That means they have y in common. Now, if you want to, and it might be a nice idea, maybe let's get rid of the fractions and let's just multiply everything by 9 before we factor out the y. It'll just get rid of the fractions, make the numbers maybe a little bit easier to see or work with. So that's going to give me 40y squared minus, it's going to end up giving me 3 times 28, or that's going to eventually give me 4, looks like. 84y. And then from there, we are going to go ahead and say, well, I maybe notice that they have a 4 in common. If you see it, great. You don't see it, doesn't matter. You can divide them by 4. You can factor out 4y. A lot of variations or options of how you want to do this. I'm going to factor out 4y, which is going to give me 10y minus 21. And now I have two things multiplied together to equal 0. And so I can set them both equal to 0. This is going to give me y equals 0. There's one possible y answer. And then this one will give me y equals 21/10. There's my second possible y answer. So now I actually know what y is. Now I'm going to go back and figure out what is x. And recommendation, anytime you are doing a problem like this where you do have a linear equation, take these answers and plug it into that linear equation that you used. You can go back to the original if you want to, or this is the same thing, just solved for x. So I'm going to plug it in here. So if I plug 0 in for y, I'm going to get x is equal to 7/3 times 0 minus 2, and of course that just tells me x is equal to negative 2. So the point would be, remember to write the x value first, negative 2, 0. There's one of them. Now if I plug 21/10 in, if you could simplify that fraction, do so, but we can't. So we'll plug that in and say x is equal to 7/3 times y, which is really 21/10 this time, minus 2. And then before you get carried away multiplying these things out, see if you can simplify. For example, I can see that 3 goes into 21 7 times. So I know this is really 49/10. Again, if you can simplify, do that. I'm going to change that to 20/10. So I have my common denominator. And it looks like I'm going to get 29 tenths. So my second point would be 29 tenths, comma, the original number I plugged in was 21 tenths. So I have two answers. I have -2, 0, and I have 29 tenths, 21 tenths. I know you're probably not liking that, but like I said, you know I love giving you fractions like that. It's a good skill to be able to do that by hand. Again, is this the only way to do this problem? Absolutely not. You could have solved for y. You could have factored out the 4 and then did your factoring. You could use the quadratic formula if you really wanted to. A lot of different ways to go about it, but this is usually the best strategy, solving the linear equation, plugging it back in, and so on. All right. The last one I'll do for you today then, solving a system where I notice both of these equations have not only square terms, but this one's even got a cubic term in it. What that probably tells me to do is I somehow need to set these equal to each other, and they did us a favor in this problem. Both of these equations are y is equal to. Well, if this is equal to y, then I should be able to just substitute it right here. In other words, set the two equations equal to each other. And that's what I'm going to do. So I'm going to take x to the third minus 2x squared plus x minus 1 and set it equal to -x squared plus 3x minus 1. And then anytime I have an exponent greater than 1 when I'm solving, I should know to set this equal to 0. So I'm going to move all this information over to the left, which is going to give me x to the third. If I add x squared, that's going to give me minus 1x squared. Subtract 3x will give me -2x, and add 1 ends up giving me 0. So we get very lucky. I don't have to do any synthetic division because there's no constant back here. I know that I can factor an x out. Saves me a little bit of time. Otherwise, we would, of course, be doing synthetic division. So if I go ahead and factor out an x, see if this can factor any further, and we get lucky. It definitely does. Looks like it factors into x minus 2 and x plus 1. All right, so I now know my three x values. I have x equals 0, I have x equals 2, and I have x equals -1. Again, this is homework, so if you did have to do synthetic division, you could easily use your calculator to help you figure out what the zeros are quickly without having to guess and check forever. On the test, your back number would be something like a 5, a 3, something that doesn't have a lot of factors so that you're not wasting a lot of time guessing and checking. All right, now I need to take this and plug it back into one of my original equations to solve for y. So I'm going to pick the one that looks easiest. I'm going to go ahead and use that one. So I'm going to just go ahead and write this down here. It is y is equal to -x squared plus 3x minus 1. And I'm going to plug in 0, and this is kind of how I show that. So I'm plugging in 0, so I got y is equal to, it's -0 squared, we know that's 0, plus 3 times 0 minus 1. I can tell that I'm going to end up with a y value of -1. So 1 point is 0, -1. All right, now let's plug in 2. So I plug in 2, and I'm going to get y is equal to -2 squared. Make sure that you do the squaring first before you multiply by a -1. Plus 2 times 2 minus 1. And if I end up going through and doing this one, it looks like I am going to end up with, where am I at here? Oh, sorry. This is supposed to be 3. I knew something looked wrong. Okay, I have -2 squared. Remember to square first. That's 4 times -1, so it's -4 plus 6 minus 1. Looks like it's 2 minus 1, or 1. So my second point is 2, 1. And my last one, plugging in -1, is going to give me -1 squared. Again, make sure that you do that squaring first. That's an easy mistake to make on a term that looks like this. Plus 3 times -1 minus 1. This is going to give me 1 times -1, so -1 minus 3 minus 1, or that looks like that's going to end up giving me -5. So my third and final point is -1, -5. And there are my three answers. And notice I've got my work somewhat neat and organized. I've got all my work here solving for the x values, then I've carried it over here to solve for the y values. It's nice to try to be organized as you can. You see, I tend to like doing things in columns. You can easily go straight down. That's not overly important. Just try to have some sort of organization and not be all over the place. Hopefully that'll help you with your homework for section 7.1.